we're just gonna be solving for the current and like the V1, V2, and V3. All right, so if we want to find the total current, first we need to find RT, since we already have the voltage total. So in this case, R2 and R3 are in series circuit, right? So using Kirchhoff's law, we just do 40 equals 60 ohms. So R23 is equal to 60 ohms. Now, if we want to redraw the circuit, because we condensed it a bit, it'll look something like this. Right. Now this is R2, 3, this is R1. Now we just do Kirchhoff's law, or Ohm's law, sorry, to find the total resistance. So we do 1 over 60 plus 1 over 30, which in this case is 1 over RT, right? Oops. RT. So we do 1 divided by 60, 1 divided by 30, add those two up, and it should equal 0.05. So you just do the inverse of this so that it becomes 1 over 0.0. And then your RT would be 20 ohms. Now, having your RT, we could just use Ohm's law. And this just gives us 0.5 amps. Now, we could solve for the currents. Okay, if we want to solve for R1 current, we know that in a parallel circuit, right, the sum of this side and this side will both be equal to 10 volts because of this. It's the Kirchhoff law parallel circuit. So I'm going to find V1, it's R1, excuse me, sorry. I1 is equal to V1 or R1. We're not given V1, but again, because it's parallel circuit, this is equal to 10 volts and this is also equal to 10 volts. The entire thing. So 10 volts, 30, around. Right. And now we know that I2 plus I3, we know that I2 is equal to I3 because it is in a series circuit, and Ohm's law is that current is constant in a series circuit. We know the I total, and we subtract I1 from it because in a parallel circuit, current is not constant. Disperses across, and we just do I2, 3. Oops. Excuse me. So then we have I2 equals 0.16 equals I3. Okay, and we have our now we have our I1, I2, and I3. And with that, we just solve for V2. We also solve for V3. This turns into And you can confirm that this is with Kirchhoff's law. If we add these two together, because in a series circuit, it should equal 10 volts. And like I said, the sum of these 2 volts here will add up to this volt because of parallels, because of the parallel rule, where voltage is constant. Okay, we're going to be solving for the total voltage, and then from there we're just going to solve the current from R1 and R2. So first things first, we need to find our voltage total. We have our current total, right? So we're just going to condense this using parallel circuits. We know that 1 over 4 plus 1 over 12, right? We just saw we should get, if we add these two together, it should give us around 0.33, and then from there we just do the reciprocal of it. So let me do 1 divided by whatever it is we get here, right? And then our RT would be 3 ohms for this. So then if we redraw the circuit, it would look like this now. It's 3 ohms. This would be R1 and 2. Then R3 will still stay 9 ohms. So now that we condense our circuit, we see that these are now in series. And Ohm's law in a series is that you could do, alright, so in this case, we just do R12 plus R13, and we just have our total as known 9 ohms. Now to find our total voltage, we have our total current here using Ohm's law. Right, can't forget this. Using Ohm's law, our voltage total is equal to the resistance total times I total. Excuse me, I made a mistake right here. It's 12 ohms. Okay. Then we solve for this. We get our total voltage to be 4.8 volts. Okay. Now here's my thought. Here's how I solve this equation. Now we're trying to find the voltage, or I mean the current in these two right here, going through R1 and R2. So how I approach this. First I find the voltage drop between this section and this section. So first we solve for voltage drop in resistor 3, which would just be R3 times I3
Man, I was so close.
times 0.4 amps. We should get 3.6 volts. Okay, using Kirchhoff's law, we know that voltage total is equal to V1 plus V2 plus V3, right? We solved for V3. We don't know what this one is. We don't know what this is. But we do know that it's constant, right? Because it's parallel in this case. So voltage is constant between the two. So we find the voltage for those two values. We just do VT minus V3 is equal to V12, 4.8 volts minus 3.6. We get that our V12 is equal to R12, right? It's constant. Voltage is constant in the parallel circuit. So then that gives us V1 and 2 right here. 1.2 V is equal to V1 is equal to V2. Again, because it's constant in the parallel circuit. And now that you have that, you have all your resistors. You can solve for the currents now. I1 is equal to V1 divided by R1. I2 is equal to V2 divided by R2. Right? divide, you should get and you can confirm using Kirchhoff's law. Again, the sum of these was equal to 0.4. Okay, so no, okay, first, we know that this is I1, this is I2. Using Kirchhoff's law, we know that if we add them up, it'll give us 0.4 amps, which is our total. And then it becomes a series with this, which is also equal to 0.4. And it's constant in a series circuit, so we know that we're right. And that's how you approach this question.